Now you're welcome to the Science Hub Academy. So where our hobby is to teach sciences and mathematics. So you are welcome to um, a refreshing course on a crash course of all the sciences. So here our focus is actually to have an interaction with the GCE students, those who are intending to write GCE, and then most likely those who will be writing the forthcoming UTME examination. So today, just like we said, what we'll be doing is just to take a review of an introduction of organic nomenclature. So naming of hydrocarbons. So, more particularly, we'll be naming the acyclic compounds, which are mostly the acyclic hydrocarbons. So we'll be working on naming of alkanes, and then you'll be working on naming of alkynes. So this is the basics of what we want to do today. So and then you want to look at the rules that guide the naming of these compounds. So the very first thing we have to do, the naming of alkanes. So the first thing we need to do is naming of alkanes. So now we know alkanes are generally hydrocarbons that are sp3 hybridized. But the simple way by which you can identify alkanes is that alkanes are hydrocarbons which have carbon-carbon single bond. And so there is a way you generally can identify those compounds that are alkanes, and we use this rudiment to also name all other compounds. So the very first thing is to identify the root word, identification of carbon chains. What do you mean by that? So when you understand the identification of the naming of carbon chains, it will be very easy for you to be able to name compounds, alkanes, alkenes, alkynes, and all other compounds, hydrocarbons. So the first thing you are going to do is the number of carbon. We can use that to actually identify. So I'm going to give you carbon number and then their root word. So we can have number of carbons. Okay, so we have number of carbons, and then you have root name. So if you have one carbon atom, the root name is going to be meth. Please, I want you to pay attention to this. So when you have just one carbon atom, the root name is meth. When you have two carbon atom, the root name is eth. When you have three carbon atoms, the root name is prop. Prop. When the number of carbon is 4, the root name is but. But. Okay. So when the number of carbon atom is 5, the root name is pent. When the number of carbon atom is 6, the root name is eggs. I hope you are following, please, everybody. So when the number of carbon atom is 7, the root name is hept. When the number of carbon atom is 8, the root name is oct. When the number of carbon atom is 9, the root name is non. And when the number of carbon atom is 10, okay, let me squeeze that one here. For 10, the root name is dec. Okay, so these are the major roots, number of carbons I'll be using in our nomenclature, 1 to 10. We won't exceed 10. And so we'll be using this technicality for the naming of organic compounds. So we'll start with the naming of alkanes, just like we said, like this. Okay, let me start here. Naming of alkanes. How do we identify alkanes? We've given the root word and then what have you. So the first thing you need to know is that carbon has 4 bonds. Carbon has how many bonds? 4 bonds. So we can use the number of bonds. Whenever you see carbon in the formation of any compound, what you are going to identify is that you realize that carbon atom is always having 4 bonds. So for example, the simplest of the alkane is for you to see carbon with 4 bonds attached with hydrogen. So we're having something like this: carbon, hydrogen, 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 hydrogen. So here we have 4 bonds. So we have H, 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 and H. So we have, this is CH4 because carbon atom is attached to 4 different hydrogens. So because carbon is attached to 4 hydrogen and we said that carbon is tetrahedral, it must have 4 bonds. So the simplest is CH4, so with a root word of meth, because we said when you have 1 carbon atom, what does that imply? 1 carbon atom implies that the compound has a root word of meth, METH. So then because it is an alkane, you are going to put the ANE. So this means methane. So that is the basic principle. So then if you have 2 carbon atoms, how do we identify that? Or how do we name that? So we are going to have 1 carbon and another carbon connected together. Now do not forget that carbon is tetrahedral, meaning that carbon has 4 bonds. So having 4 bonds implies that each part of carbon is going to have 1. Yeah, see, this is 2, 3, 4. 4 carbon atoms. 1, 2, 3, 4. So we can then saturate them with hydrogen. So this is going to be H, 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 and H. Looking at this, there are different ways by which we can actually name this. So in naming this, the first carbon atom is going to have 3 hydrogens. So that will be a CH3. So 1 carbon atom with 3 hydrogen attached. Then the other one also will be having CH3. So you can see the first carbon here is having how many hydrogen attached to it? 3 hydrogen atom. 1, 2, 3. So that's why we are writing it as a CH3. The second one is also having 3 hydrogen. The second carbon atom is also having 3 hydrogen attached to it. 1, 2, 3. So that's why we also have the second CH3. So this can be CH3CH3, which can also be written as, how many carbon atoms do we have in all? We have 2 carbon atoms in all, so that is a C2H6. So we have 2 carbon atom and 6 hydrogen. So now because it is an alkane, it has a carbon-carbon single bond, right? And then it is having 2 carbon atoms. So the root word there is going to be an S, ETH. You said that. So therefore, in an alkane, we add the prefix, so that becomes ethane. So that is the basic way of, that is the simplest way of naming hydrocarbons. So we have been able to name the first alkane, which is the methane, with a CH4. The second one, CH3CH3, which is also C2H6. Now if you continue naming them that way, if 3 carbon atoms connected together, so we have in this way 1, 2, 3. So for each carbon atom need to have 4 bonds. The first one, then 2, 3, 4. That is complete. This is also going to have 1, 2 already, 3, 4. Then you have 1, 2, 3, 4. So it must have 4 bonds. So, and you've connected all the 4 bonds, then we need to populate the other with hydrogen. So this is going to be hydrogen, 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 and hydrogen. So in all, the first carbon has 3 hydrogen, so that's a CH3. The second one has 2 hydrogen, that's a CH2. The third one has 3 hydrogen, that's a CH3. So we have CH3, CH2, and CH3. So that's what we have. So in a nutshell, we can also write this as C3 because you have 3 carbon atoms. Then 2, 5. We have 5, 8, H8. So the total number of hydrogen here is 8. 3 plus 2, that's 5. 5 plus 3, that is 8. So the number of carbon atom you are having there is 3. So the root word there is a prop. So because it's carbon-carbon single bond, this is a propane. So the name of this compound is what? Propane. Right. So the next one is the one with 4 carbon atoms. So we'll be having something like this. 1, 2, 3, 4. Right? So let's populate that also with hydrogen. It has to be 4 bonds. So to make it 4, so we have just 1 carbon here. 2, 3, 4. And this is 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So then we add the hydrogen. Hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, here, hydrogen, 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 hydrogen. So we've populated everything with hydrogen and the 4 carbon atoms. And so this can be written as a CH3, right? A CH2, another CH2, then a CH3. So let's count the number of carbons. So this can also be written this way. The first one is having CH3. Now we have 2 CH2. There's one CH2 here, there's another CH2 here that are connected to each other. So this becomes CH2 in 2 places. So we can write it into a bracket and then you put 2 down here. So and then you have what? CH3. So this is another way of writing it. Then we can also write it in this form. Now we have how many carbon atoms? We have 4 carbon atoms, so that's a C4. How many hydrogen? So let's count the number of hydrogen we have there. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have H10. So this compound here, right, is called butane because the root word from which it is obtained is but. We said when the number of carbon atom is 4, that the root word is a but. But because it is an alkane, because it has carbon-carbon single bond, so it's going to be a butane. So this is a butane. Now, so if you move further, we can do the same thing for other compounds too, till we get to with up to 5 carbon atoms like this 1, 2, 3, 4, and 5. So this is 5 carbon atoms. So we can also populate this with hydrogen. So we'll be having something like 1, 2, 3, 4. So this is okay. So this is like this. So you must ensure that each carbon atom has 4 bonds. That is what is most important here. So then this is hydrogen, 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 hydrogen this way, hydrogen here, hydrogen here, hydrogen here, hydrogen here, and hydrogen here. So in all, this can be written as CH3, right? Then you have a CH2, Then you have another CH2. You have CH2 in 3 places. You have one CH2 here, one CH2 here, one CH2 here. So this is another CH2, and then you have a CH3. Okay, so summarily, this can be written as CH3, then CH2 in 3 places, right? Then a CH3. So now this can also be written as C. How many carbon atoms do you have? 1, 2, 3, 4, 5. C5. H. How many hydrogen atoms? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So that is it. So you have a C5H12. And so when the carbon atom is 5, the compound is a pent. So that is pentane. That is a pentane. So this is pentane. So this is exactly how you continue naming all other given hydrocarbons. So but before I move into other aspects, let me take 2 more so that we can proceed. Now when the number of carbon is, for example, 7, so we'll be having something like this: 1, 2, 3, 4, 5, 6, and 7. That's the basics, right? So let's saturate them with hydrogen. So we have 4 bonds here. So each will have hydrogen populated with them. So this is going to be hydrogen, 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 hydrogen here, hydrogen here, this way, hydrogen this way, hydrogen, 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 and hydrogen. So there should be 1 hydrogen here because of the space. Now to write this in all, so that is the structural formula. We can change this to the condensed formula. So the first carbon atom has 3 hydrogens attached, so that's a CH3. The next one has 2 hydrogens, so that's a CH2. So in how many places do you have the CH2? Let's count them. So you have CH2, 1, 2, 3, 4, 5. You have 5 CH2, so that will be CH2 in 5 places. And then you have CH3. So this is how to write this. And again, we can also write the molecular formula. So how many carbon atoms? You have 7 carbon atoms. That's C7. So how many hydrogen atoms in all? So when we count that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's H16. So we said when the number of carbon atom is 7, so that's an hept. So this is hept, but because it's an alkane, so that will be heptane. So this is heptane. So that is the basic principle we use in naming alkanes, especially single straight chain alkanes. Now, after understanding this pattern, so alkanes generally used to have a formula. We call it the general molecular formula of alkanes. So the general molecular formula of alkanes is CnH2n plus 2. CnH2n plus 2. So where the n there represents the number of carbon, n equals to number of carbon attached. N represents what? The number of carbon attached. For example, if the number of carbon is 1, so you just replace that 1 into this general formula. What are you going to have? You have C1 H2 bracket 1 plus 2. So what will this give you? It will give us C1 H. 1 times 2 times 1 is 1 plus 2, that's a 4. So that's the same as what? CH4. Now because we are using the general molecular formula of alkane and it has just 1 carbon atom, so this is going to be methane. Now if the number of carbon atom is 2, so we'll be having something like this: n equals to 2. So following the general formula, we'll be having C2 H brackets 2 brackets 2 here plus 2. So that will give us C2H. Now 2 times 2 is 4. 4 plus 2 is 6. So we'll be having this C2H6. For 2 carbon atoms, you'll be having what? Eth. So because it's an alkane, that will be ethane. Right. So we proceed also for others. Let's assume that the number of carbon is 5, for example. C using Cn H2n plus 2, where n equals what? 5. So this is going to give us C5 H bracket 5. This is 2 5 plus 2. Then this is going to give us C5 H. This is 10 plus 2, that's a 12. So that's C5H12. So the name of this compound is what? Pentane. Now we can continue like that for others. Let me give you one more, then we will proceed. So we can also have when the number of carbon is equal to 8, for example. So that will give us C8 H2 bracket 8 plus 2. So this will generally give us C8 H2 times 8. So that is 16. 16 plus 2. So that is 18. So that will be C8H18. So this is the name of this compound for when carbon atom is 8. So that will be octane. So this is an octane. Okay. So that is that. So you are following this principle to name all other organic compounds. Especially if it's an alkane, just use this to identify a straight chain alkane. So that is number 1. So what are the common substituents that we have? So the common substituents are, for example, we have a CH3. Okay. Now this CH3 is called methyl. It is a substituent and it is obtained from alkane. So it is obtained from from methane minus 1 hydrogen. Okay. So we call it the methyl, or some call it methyl, as the case may be. So another common substituent is C2H5. So this is known as ethyl or ethyl. It's also obtained from what? Ethane. So when you remove 1 hydrogen from ethane, you are going to have this. So this compound can sometimes be written as CH3CH2. They are attachments. So either it is this way or it is this way. You are referring to the same thing. So this is called ethyl or ethyl. So other ones include stuff like you have Cl. So this is called chloro, being an attachment. We call it chloro. Then we can have Br, that is a bromo. Right, so chlorine. So being a substituent, it will be called chloro. Bromine being a substituent, we will call it what? Bromo. So we have others too, as the case may be. So if you have I, so this is going to be called iodo, and so on and so forth. So these are some of the substituents that we have, and there is a need for us to know how to name them in a given structure. Now, haven't identified this, we need to look at them in structures and know how we generally use them in naming compounds. Rules of naming alkanes. What are the rules we use in naming alkanes? Then we use those rules to name some alkanes, and then we see how easy it can be. Now, the first rule is to identify the longest carbon chain. Identify the longest carbon chain. So you need to identify the longest carbon chain. So for example, when you have something like this, carbon, carbon this way, right? And then you have something like this also. Now let's identify the longest carbon chain here. The longest carbon chain must be continuous, right? And it must not break up. So don't rest one more. For example, in this compound here, the longest carbon chain will be 1, 2, 3, 4, 5. So here will be the longest carbon chain. So it is continuous and it does not break. So 1, 2, 3, 4, and 5. So that's the longest carbon chain. So as for this, here is a substituent. That C here is a substituent. So it's just an attachment. So if you look at this other one too, we have 1, 2, 3, 4, 4 carbon atoms. So this is the longest carbon chain here. So that being the longest carbon chain, it implies that this is just a substituent. So the first rule is to identify the longest carbon chain. So the first one here, we get to realize that the longest carbon chain here is 5 carbon atoms. So the parent name here will be pentane, because it is carbon-carbon single bond, so it's a pentane. And as for this, the longest carbon chain is 4, so the parent's name is going to be butane. So this is a butane. So you have a pentane and then you have a butane. So now after identifying the longest carbon chain, the next thing, the second rule, is identifying the lowest substituent possible, or locating the substituents with lowest numbering possible. So we're going to see how that is feasible. So whenever you're having an organic compound, which possibly, let's give an example, C, 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 let's say we have something like this. Now this one is not complete, so we need to write the structures in such a way that it's going to be complete. And so what do? You have 1 carbon atom here, 2, 3, 4, that makes it 4 here, 1, 2, 3, 4, then you have 1, 2, 3, this is going to be 4, then 2, 3, 4. So this is going to be H, H here, H here, H here, H here, H here, right? Something like this. H, 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 and H. So this is actually what we have, so that we can know how to name the compound easily. So the longest carbon chain possible is 4. These are the longest carbon chains that we have. So we have 4 carbon chain, that is the longest. And then, being the longest carbon chain, we can identify the parent's name. It's an alkane because it's a carbon-carbon single bond. So the parent's name of this compound is butane, 4 carbon atoms. So that it's a butane. And so we're having a substituent here. This is a substituent. So the substituent is a CH3 substituent. Okay. And we know CH3 substituent. And the CH3 substituent is called the methyl or methyl, as the case may be, depending on how you call it. So now let's see what we can do here. We need to identify the lowest numbering possible for the methyl, for the CH3. So how do we identify the lowest numbering possible? So what we do is this. we give them the number from left to right and from right to left. So we are going to number the carbon atom from left to right. So let's assume this is carbon 1, carbon 2, carbon 3, and carbon 4. So we are having 4 carbons. So from left to right, we realize that the position of our substituent, which is the CH3, is on carbon 3. So we write 3 here. So when we take the other position, okay, so this is going to be carbon 1, carbon 2, carbon 3, and carbon 4. So taking that other position, what do you observe? We observe that the substituent from right to left is on position 2. So we go for 2 here, so you put 2 here. So what is the implication? Now we are going to, according to the rule, we are going to consider the substituent with the lowest numbering. So the substituent with the lowest numbering here is 2, and 3 is higher, so we don't go for 3, we are going to go for 2. So we are taking this position from right to left. So it means the position of our methyl, which is the CH3, is on position 2. So we are going to have 2 methyl. So that's the substituent. The substituent is a 2-methyl. So how do we then name this compound? The name of the compound becomes 2-methyl. So that's the substituent first. Then what? The parent name, butane. So the compound is 2-methyl butane. So that is it. Yeah, I hope is it clear? Because we proceed. Can you hear me?
Yes, sir.
Okay. Next, carbon, carbon, something like this. Okay. Now, when you have something like this, let us complete the compound. So this is going to be like this. Okay. So every carbon must have 4 bonds. So you have a structure like this, an organic compound, which is an alkane. So looking at this, let's count the number of carbon atoms. Let's get this longest carbon chain first. So I think the longest carbon chain should be, let's see, 1, 2, 3, 4, 5. I think it should be 5 at all respective pattern. So we are picking 5. We can pick this straight one. So that is it. So it means that this one is a substituent and this is also a substituent. So you're having 2 major substituents here, which are CH3 substituents. The first thing we do, now this compound given here can be drawn in another way. So in case you have it this way, so this first one here is a CH3, so it is CH3. I want to redraw it. Then this is a CH2. Then this is a CH3. Right, so then here we have another CH3. Then you have a CH3. So the compounds are the same, just that one is a structural formula and the other is a condensed formula. So the longest carbon chain there is 5. Is it 5? 1, 2, 3, 4, 5. Yes, 5. So it means the parent name would be 5. So that is a pent. So that is a pentane. Okay. So pentane is our parent name. So let's identify the position of the substituent from right to left and from left to right. So if you are picking the position here, let's give it a number first. So we are having carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Okay, now we're having 5 carbon atoms as we said, and then let's identify the position of the substituent from left to right. So the first carbon atom is on position 3, so let's write 3, right? So the second one is on position 4, let's write 4. So we have 3 plus 4, that is a 7. So it means when we take the position from left to right, so the total substituent is 7. Then let's look at it from right to left. So this is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So if you are picking it that way, let's look at the position. Right, so the first one is on position 2 plus the other one is on position 3. So if you add the two together from right to left, you'll be having what? 5. So this is wrong and this is correct. So we are going for the lowest numbering possible. So we take 2 and 3. So but you realize that the substituent here are methyl, which are CH3. You have two CH3 there. One of them is on position 3 and one is on position 2, since this is the position we are looking at from right to left. So we're therefore going to say that this compound is going to be 2. It is 2 methyl, and it is having another what? 3 methyl. So when you have methyl, the same substituent repeated twice, so we are going to use the word di for it. So it simply means that this is going to be called 2, 3. So you put a comma showing that they are of the same substituent. So you have 2, 3, then you have a dimethyl. Okay, so the compound here, the substituent of this parent chain is a 2, 3 dimethyl. So you know, to therefore name the whole compound, you start from the substituent and then you end with the parent's name. So the organic compound here, the name is 2, 3, 2, 3 dimethyl, okay, dimethyl pentane. So 2, 3 dimethyl pentane. So that's the name of the compound. 2, 3 dimethyl pentane. So that is it. On you. So if I want to redraw it, I can redraw it. One, how many carbon atoms here? H, H, H. Then I have a C with one H up and one Cl down here, because I have CHCl. Then I have another carbon with 2 hydrogen, H up, H down, that's the CH2. And then I have CH3. This is what I have. Now, from this, I can identify the longest carbon chain. The longest carbon chain is definitely 4. Okay, so it means that the parent's name is a but, because it is having 4 carbon atoms. So this is a butane. Now the next thing is to identify the substituent. The substituent here is chlorine, is Cl. So it's a chloro. So let's identify the lowest numbering possible. So I need to number it from left to right and right to left. So this is going to be carbon 1, carbon 2, carbon 3, and carbon 4. So my chlorine is on carbon 2 from left to right. Now let me take it from right to left. So if I'm taking it from right to left, carbon 1, carbon 2, carbon 3, carbon 4. Okay, so that will be what? The Cl is going to be on carbon 3. So I go for the lowest numbering possible. So I go for 2, I neglect 3. So it means my substituent is on position 2. So that is a 2. Now what is therefore going to be the name of the compound? The name of the compound will be 2-chlorobutane. 2-chlorobutane. So that is the name of this compound, 2-chlorobutane. Are you following? Now I'll give you 2 to 3 questions for you to attempt, and let's see how you'll be able to attempt it. Are you ready? Two
Bromo.
bromo
Yes. Butane.
butane. Okay. What about the second one?
2,3
2,3
dimethyl butane.
dimethyl butane.
Butane.
Yeah. So I think that's correct. So the first one is 2-bromobutane because the longest carbon chain here is 4, right? And so the substituent with the lowest numbering is position 2. 1, 2, 3, 4. So we go for 2. So that is a 2-bromobutane. That's correct. And if you look at the second one here, what is the longest carbon chain? That is 4 also. So, and the substituent is position 2 here and position 3. So that was very correct. So you got them right. So let's proceed. Something like this, a CH3. You have another CH3. You have H, C, H, CH3 and a CH3. Can you see this? So how do we unfold things like this? You just restructure it, make it look straight. So if we want to do something like this, we just follow the normal regular pattern. So I can take the longest carbon chain as usual. So if I start from this, I can redraw this thing like this, CH3, to make it straight. Then CH. So this carbon atom can have this CH3. So you can see what I've done. I've only straightened these two, this one and this one, to make sure that they align with this carbon atom. So then this is going to be a CH, right? And then I have one CH3 here and one CH3 here. Does that make sense? So it's just the
Yes,
same
sir.
thing. So we just needed to align it to ensure that it is done in the correct orientation. So from this, the longest carbon chain is also what? 4. 1, 2, 3, 4. So we take 4. And so we take the lowest numbering possible. So here we have our methyl and then you have another methyl. So which are on position 2 and 3. Either from left to right or from right to left. So if you take the numbering here, this is carbon 1, carbon 2, carbon 3 and carbon 4. So this will be 2 plus 3, which is 5, and the other position 2 will be 5. So whatever situation you have, you are going to have 2, 3 dimethyl butane. So that will be 2, 3 dimethyl butane. I hope that one is clear. Now let's proceed. And then you have something like this and this. Okay. Maybe a CH3 here. So if you have something like this, how best can we name a compound like this? So we follow the regular pattern. The first thing is to identify the longest carbon chain. So how do we get to know the longest carbon chain? So how many carbon atoms? 5. 1, 2, 3, 4, 5. I think it's 5 also. So this is the longest carbon chain, 5 here. So these are the substituents, Br, CH3 and Cl. So you can see here we have different substituents. So the first thing we do is to identify the substituent with the lowest numbering. The parent's chain or the parent's name is pent, so it's a pentane group. So but let's look at the substituent. But before we do that, we need to give it number. 1, 2, 3, 4 and 5. So when you take the numbering from left to right, So this is on position 3. The bromine, the first substituent, position 3. And I have two substituents on carbon 4. This one and this one. So I'm going to write 4 in two places. 4 plus 4. So let me add all of them together. So that will be 3 plus 4, that's a 7. 7 plus 4, that's 11. So this is going to be 11 here. So if I take the other side, so I'm going to have this way 1, 2, 3, 4, and 5. So in this situation, my CH3 and my Cl are in position 2, so I'll write 2 plus 2, right? And then what else do I have? I have my Br on position 3. So that is 2 plus 2, 4. 4 plus 3, that is a 7. So this is 7 here. So this is 7 and this is 11. So I go for the lowest numbering. So I'm going to rather take 7 than taking 11. So that means I will maintain the counting from right to left. So then let's look at the position. So my chlorine is on position 2, so it is a 2 chloro, right? And then and the methyl is on position 2 also, so we have 2 methyl. While the bromine is on position 3, so we have a 3 bromo. Now, but to write the name of the compound, so we need to write them alphabetically. So bromine comes before, B comes before C, and then followed by M. So if you have to follow that logic, we are going to start with bromine as a substituent. So the name of this compound will be 3 bromo. Okay. Then you have 2 chloro. Then we have 2 methyl. And then you have what? Pentane. So the name of the compound here is 3 bromo 2 chloro 2 methyl pentane. So that's the name of the compound. 2 bromo 2 chloro 2 methyl pentane. So that is how you name simple alkanes using this principle or phenomenon. Naming of alkenes. Okay. So how do we name alkenes? It's just like the naming of alkanes too. So following the number of carbon root word and then identifying the functional group. So first, you must know that alkane must have double bond, at least a double bond. Generally, alkanes used to have double bond. So and that is the functional group. If I have a compound that is having carbon-carbon single bond without a double bond, so that can never be an alkane. Alkane will have at least one double bond, so making it an alkane. So if it is having more than one double bond, maybe it can be a diene or a triene if it is three double bond and so on and so forth. But our focus here now is to name alkenes with just one double bond. So the simplest alkane is the one with two carbon atoms because there must be carbon carbon before the double bond. So that will be carbon carbon with a double bond this way. Do not forget that every carbon must have four bonds. So if I'm having carbon carbon double bonds, so this is going to be 3 4. So this is now 4 now. 1 2 3 4. That's complete. 1 2 3 4. This is now complete. So I can then saturate it this way. So I can rewrite this as CH2. No, close it down. Double bond CH2. Mosquito. Now this is a CH2 double bond CH2. Or sometimes we can write it as what? C2H4. C2H4. So what's the name of this compound? The name of the compound is what? Earth. From the root word, two carbon atoms. But because it has a double bond, it's an alkene. So that is going to be what? Ethene. I have something like this also, three carbon atoms. So, and I have a double bond here. It's going to be 1, 2, 3, 4, 4 this way. So, this is going to be like this. So, this is going to be CH2. That's another way of naming of writing it with a double bond and a CH and a what CH3. Okay, so this is having how many carbon atoms? Three carbon atoms with a double bond. So that's a prop. So this is called propene. I hope I'm talking.
Yes, sir.
Okay, now one, two, three, 4, 5. Can I have a double bond? Not necessarily this position. I can put it here. So then this is going to be like this. Now for this, we know this can be written as a CH3, CH2, CH2, CH double bond CH2. Okay, so or we can write it as C. How many carbon atoms? 5 carbon atoms. H. How many hydrogen? 10. So this is pentene. So this one can also be called pent 1-ene. So because of the position of your double bond. So because it is also possible we have in with different position. So this is what I mean. We can have pen 2 in like this. 2, 3, 4, 5. And you have a double bond here. So this is going to be like this. H, 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 this way. Right? So if you look at this one, it's a bit different because it's also a carbon hydrogen with a double bond, but the position of the substituent is a bit different, and that is one thing we need to note whenever we are naming alkanes. So this is the longest carbon chain, right, where the double bond is included. So if you are naming them, it's going to be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So your double bond from left to right is between 3 and 4. So let me take 3 for example, because it's between 3 and 4. So 3 is a lower number. So if I take the other positioning, right, so I'm going to have carbon 1, carbon 2, carbon 3, carbon and carbon 5. So that is between 2 and 3. So 2 is a smaller number, so I go for 2. So I neglect this position because this is higher. I take this position. So it is 5 carbon atom is a pent. So that's why this is going to be pent 2-ene. We call it 2-ene because the position of the double bond is on position 2. Okay, so this is called pent 2-ene, or we can call it 2-pentene. So it's the same. Pent 2-ene and 2-pentene are the same. Is that clear? Yeah. The alkanes, they have a general formula. So alkenes, I mean, have a general formula which is CnH2n. So this represents the general formula for all the alkenes. So where n represents the number of carbons. So if n is equal to 3 for example, so note that n is always greater than 1 for alkenes. So there is nothing like n equals to 1. So if I have n for example to be equals to 3, so how am I going to draw the whatever? So that will be following the general formula. That will be C3H2 bracket 3. and that will give me what? C3H6. C3H6. Okay, so this is propene. If I have N is equal to 6, for example, so this is going to be C6H2 bracket 6. So that will give me what? C6H12. So that is what? Hexene. Okay, so that is hexene. C6H12. This is called hexene. So we can proceed for other compounds too, following the same regular pattern. So we always see them to be fascinating using this pattern. Let's look at the rules first. Rules of alkenes. The first one is also to identify the longest carbon chain. You identify the longest carbon chain with the double bond inclusive. So when you are identifying your longest carbon chain, your double bond must be included. So for example, you have C, 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 C here, right? Now, if you look at this, what is your longest carbon chain? Your longest carbon chain is the one where the double bond is inclusive. So it has to be this one here, because that is where the longest carbon chain is included. And so that is 4 carbon atoms. So normally if you are to look at how to name this compound, we will see that this is one. Let me complete that. You have H, H, H like this. Okay, so you have it this way. Now, but I think this is not correct. You are having an extended octet. This is how you identify. This one is more than 4, so this is an extended octet. This one is not supposed to be there. Alright, it's okay like this. Now, the longest carbon chain, as we said, is 4. So, and the parent name there is boot. So that is a butene, or we call it boot 1 in, because the position of the in is still between 1 and 2. So since what you have identified is that this double bond that is maintained is between this carbon 1 and carbon 2. So that means you have taken this position from right to left. So it means this is my substituent. And this substituent is CH3 and it is on position 2. So this is a 2-methyl. So what is now going to be the name of the compound? The name of this compound will simply be 2-methyl, right? Butene. 2-methyl butene. That's the name of the compound. 2-methyl butene. Okay, you really do not have much time. Again, I think you have less than 8 minutes. So let me see if I can take one more example. See. Okay. Now let's pick this for example. So for this is an alkene, so we need to identify the longest carbon chain. Or do you have anyone who can try this? Can you try it, everybody? So how do you solve this question? It's quite easy. So we need to identify the longest carbon chain as usual. So the longest carbon chain here is going to be 5. So we can pick it this way, like this. So this is the longest carbon chain. So carbon carbon double bond, that's an alkene. So since it is having 5 carbon atoms, so but we need to know the position of the double bond. So if you number them from 1 to 4, so from left to right, so this is going to be carbon 1, carbon 2, 3, 4, and 5. So from left to right,
Sir,
yeah.
can I say what I got? Like
Okay, let me hear you.
3 bromo,
3 bromo,
mm-hmm, 3 methyl,
3 methyl,
pen 2 in.
pen 2 in. So
I
you
be
see,
pen 3 in.
is it pen 2 or pen 3? Which one are you taking?
Wait, 1, 2, 3. Pen 1, 2, 3, 3.
Are you sure it's 3?
Sir, 3 in.
Okay, so let's see. Now, if you look at the numbering from left to right, so you get to realize that the double bond is between 2 and 3. So in between 2 and 3, which one is smaller? 2. You write 2 here. Now, if you take the other position, right, this way, from right to left, this is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So which one is actually smaller? This is between 3 and 4, so this is 3. So I neglect 3, I go for 2. So that means I'm going to maintain 2 to what? I'm going to maintain the position from left to right. So what is now the position of the substituent? Number one is that the parent's name is 5 carbon atoms. So this is pen 2, it's not pen 3. It's pen 2 in. Are you clear with that? I hope that's clear. Then next is that let's identify the position of the substituent. There's one substituent here, there's another substituent here. Don't forget that we've actually confirmed the position we are taking, which is from left to right, since that is 2 or position 2 for the substituent. So that will determine how we are going to move. So the Br there is on position 3, so that is a 3 bromo. And the methyl is on position 4. So that is a 4 methyl. Okay. So it means that this compound will therefore be, you need to arrange them alphabetically. So what are you starting with? You are starting with bromine as usual. So this is going to give you 3 bromo, right? Then 4 methyl. Are we together? Then pent 2 in. Is that clear?
Yes, sir.
So this is the name of the compound.